formula packet and your binomial table. So get out a copy of each of those right now so we can make sure we understand how to use them. I told you that I wanted to spend today going over the second review packet because we had a couple days in class for the first one. And so I think a lot of you have gotten your questions answered over that. If we have extra time, once I'm done, then I'm happy to go over anything from the first packet that we need to. Otherwise, you can come in and check it whenever if you have some that you need to look at. So we're looking at the Review B packet. And I'm just going to attempt to work through everything if we can. Is that okay with you guys? Okay. So suppose you and a friend are playing a game where 2 dice are rolled. If you roll a 5 or a 9 on the first roll, you win. If you roll a 4, 6, or 8, you lose. I probably should have been a little more clear, so let's assume regular 6-sided die, everything equal probability, so no tricks here. So you win if you get a 5 or a 9. So you could win by getting a 1 on the first and a 4 on the second, or it could be a 4 on the first and a 1 on the second, 2 and 3, 3 and 2. Let's see, or we could get 9s. So 4 and 5, 5 and 4, 3 and 6, 6 and 3, and that would be every way I could win. So we could lose if we get a 4, 6, or 8. So to get a 4, 1 and 3, and 3 and 1, 2 and 2. To get a 6, you could have 1 and 5, 5 and 1, 2 and 4, 4 and 2. 3 and 3, so that's all my 6s. To get an 8, you could have 2 and 6, 6 and 2, 3 and 5, 5 and 3, or 4 and 4. Alright, so everybody understand my sample space? So sample space is listing everything out. FYI, there are going to be, I have a question on the test that has just a matching section with like 5 or 6 definitions, and it's matching them. So I've got the word, I have the definition. Sample space is going to be one of those. So make sure you know what a sample space is. It's just listing all the possible outcomes. Okay. So then we wanted part B, the probability you win on the first roll. How many combinations are there when you roll dice? You get 6 options for the first, 6 for the second, so there are 36 altogether. To win, we had 8 options listed, so 8 out of 36, which gives us 0.2 repeating. To lose on the first roll, so there's 36 total options. 13 of them lose. So if you divide, you get 0.3611. So we have our probability of winning and loss. Yeah. Are we good with number 1? So very likely that I might have a dice option. We've had several of those. We did some class examples. We've had them on homework. We've had them on a couple of the packets that I've made you. So there might be something along those lines on your test. Number 2. All right. If I ask you why something is a probability model, there are 2 things that you have to tell me. What are they?
Have to be between 0 and 1, and you have to have.
Yes. So, might put that on your test. Verify it's a probability model, and I will be looking for more than just yes. If I say verify that it is, tell me. Every probability is between 0 and 1. And they add to 1. All right. So B, what's the probability that a person travels in a car? So look at our means of travel. Which of those would be traveling in a car?
Driving on carpool.
driving alone, and carpool. So we just add those together. The other, public transportation is in a car, walking, other means, working at home. So we don't need those. So we just add these two options, and we get 0.875. What's the probability that the person drives alone, with someone, or on public transportation? Or means what? Add. So I'm just asking you to add three things together. So drive alone, or with someone, so that would be carpool, or public transportation. So we get 0.925. The probability that a person does not walk, what would we do? 1 minus. What's a word for the opposite like this when you do 1 minus? So our terms that will probably be matching at the end, complement would be another one. The opposite of something, 1 minus. Everything not in our original set. Okay, are we good with what sample space and complement mean? All right. Number 2, okay? Number 3. Suppose this hitter successfully reaches base 30% of the time he comes to plate. What is the probability he reaches base 3 times in a row? Are these independent trials? Yes. Okay, it didn't say anything about him getting better as he bats. It's just 3 separate times. Each time he has a probability of 30%. So the probability of 3 times in a row, you just have to do 0.3 3 times, or to the 3rd power, and we get 0.027. If you're looking on your formula sheet, you know this is just an and. I want to make it to base, and make it to base, and make it to base. So that's just our multiplication rule. B, the probability he will not make it to base in at least one of the next 10 bats. Okay, there are tons of combinations that would make him not make it at least once, right? He could only not make it 1 time, but it could be the 1st, or the 2nd, or the 3rd, all the way up through the 10th. Or he could miss it 2 times, or 3 times. It's going to take us a long time to count up all those options. But not making it at least once is just the opposite of making it every time. So all we have to do is 1 minus the probability that he makes it 10 times. So just 1 minus your 0.3 to the 10th, which is, yeah, you get a lot of decimals here. So extremely likely that he is going to miss at least once. Huh? Not very likely that he will make it. All right. Number 4. Talking about terms on this one. These I said were independent. Independent would probably be another one of those terms. Independent events. Basically, independent events don't have anything to do with one another. Knowing one thing happened doesn't change the probability of the other. Okay, knowing that food science went to nationals today does not change the probability that the sun is shining. Okay, they have nothing to do with one another. All right. Number 4. A committee of 4 women and 3 men will select 2 people to attend a conference. What is the probability that 2 women are selected? So we want the probability the first is a woman and the second. And means what? Okay, so we know we're going to be multiplying. If I have how many total people? 7. How many of them are women? 4. If I select a woman, then for my next person, how many are women?
3,
Out of
7, or 6.
6, because we already took one out of our group. Okay, so when you multiply those, we get 0.2857. So the next piece talks a lot about conditional probabilities. So that is when we have those givens, when we have a condition. So it's the probability if something else has already occurred. So the probability of me reviewing today, knowing that I told you last week we were going to. Okay, so something has already happened. What's the probability of another event occurring? All right, so on these, let's kind of run through these. If I did give you the total along the bottom, so we have paved and unpaved runways. So part A, the probability of being paved. So is there any kind of condition here? Do I know anything already? No, so it's out of everyone. So if you add up, just add up the two totals, the 5146 and the 9805. So altogether, we have 14,951. The numerator, how many of those are paved? Make sure you're looking at that table and tell me if you don't know where I'm getting any of these numbers. So B. Again, it doesn't give me a condition, so it's out of everyone. On the top, it says we are looking at 914 to 2437. I really need a copy of this table. All right, let me get a copy here so I can show you what I'm putting together. All right. So we have to figure out what goes on the top. We are looking at everything for our total. And then I want everything that is 914 all the way up to 2437. So what we have to do is add these four numbers together for the top of our fraction. So we get 5661. So our probability is 0.3786. C. I gave you, this is asking for an and it's really tempting when you see those ands to try to do a formula, but if we have the table, we may not have to. I want it to be less than 1524. So less than 1524 means we have to be in one of these two. And unpaved. So I can look, these are the two numbers that are less than 1524 and unpaved. So if we add those together, and it's out of everybody. D says more than 2437. So that means it's got to be in one of these two. And paved. I look at my two paved ones there. If you add those together, you get 417 out of 14,951. E, this is a conditional because it has a given. When you see the given, that's what goes in the denominator. So the given is more than 1523 meters of runway. So everything more than 1523 would be these 6 numbers. So if we add those 6 numbers together, what do you get?
143.
Then the top, I'm still only looking at those highlighted numbers because I already knew that part was true. And then I want the paved. So we add the 3 paved ones together. And we get 1,881. So when you have a conditional, that's the only thing you're looking at. The condition is your denominator, and the numerator is just looking at those numbers. F, I have a given. Given it is unpaved. So my denominator is all of my unpaved, which we had the total 9805. Out of those, I want less than 1524. So that would be these 2. We get 9643. And that's 0.9835. G. Unpaved, knowing it has less than 1524. So my denominator is less than 1524. So my denominator is these 4 numbers. So that's 12,908. My numerator is just the ones that are unpaved. So 9643. Do you guys understand this conditional? What if I asked for the probability that it is paved and unpaved? And. That it is both paved and unpaved. 0. Why? Yeah, what do we call those when there's 2 sets and they can't both happen at the same time? Mutually exclusive. That's an impossible event to be in both of them. The reason that is mutually exclusive. So that would be another term to add to your list.
Wait, can you say the example again of equals
I said what's the probability that one runway is both paved and unpaved? And it was 0 because it couldn't be both. So 2 events that can't both occur are mutually exclusive. So far I told you there would probably be 6 terms, and I've given you 5 of them so far. All right. Then we got into question number 6, talking about our variables. Discrete or continuous, what's the difference?
discrete is a definite number, continuous there's multiple variations.
Okay, so the number of saved telephone numbers on a person's cell phone. Could I go through your phone and count how many numbers you have?
Yeah.
Yeah, so discrete. All right, when you list the possible values, you don't want to say x is greater than 0, because that's implying it could be 0.5, 0.7, 0.75, and we can't really have decimals. So what I want you to do, could it equal 0?
Yes.
Okay. So we would say 0, 1, 2, 3, and so on. So just showing me it has to be those positive whole numbers. B, the weight of a statistics textbook. If it can be decimal, it's usually continuous. We know we couldn't have a negative weight. Can you have a textbook that weighs absolutely nothing? No. But we don't really have a maximum weight either. So in that case, because it could be the decimals, we'll just say greater than 0. X is greater than 0. Because we could not list out every possible weight of a textbook. Is this helping, guys? Number 7. So we've had some of these expected value questions, so you'll probably have one on your test. Most of the ones I've given you are kind of like the life insurance question, which we had on the first review packet. We've had that one like 4 times now, so probably something like that. This is a different situation, but the same idea. So we have in a game of roulette, a player can place a $5 bet on the number 17 and have a 1 in 38 chance of winning. If the ball lands on 17, the player wins $15. If not, the casino keeps the 5. What's the expected value to the player? So expected value is just another way of saying mean. This is really a binomial situation because either they win or not. And the probability of winning is the same every time, the probability of not winning is the same every time. So this would probably be your 6th term, knowing what a binomial experiment is, that there's 2 possibilities, either success or failure, same probability every time, set number of trials. All right, so when I look at this, for the person, there are 2 options. They can either lose the $5 or they can win 17, right? So let's talk about if they lose the 5, so that would be a negative. What is the probability that they lose? 37 out of 38 times they will lose. Now, if they win $15. Are they actually getting a profit of 15? No, they're really only getting 10 because they paid $5 to play, so they're really only gaining $10 here. And there's a 1 in 38 chance of that. Since this is binomial, all we need is the mean. And on our formula sheet, it says that's the sum of, well, we're doing a probability table, so I guess we really don't need the binomial formula. We could treat it like the others, x times p of x, since we already have it set up like this. Probably be a little bit easier. So we just multiply these. So negative 5 times 37 out of 38. And 10 times 1 over 38. So we add those up. I'm going to go ahead and round to 2 decimal places just because we're talking about money. So in general, you're expecting to lose $4.61 when you play this game. So if I'm asking about the expected value, we're really just finding the mean. Is that one okay? All right, so the next one, according to a survey, wrong study guide. We have the probability distribution, and I'm asking you to make the table. So this isn't hard, but it'd probably be a lot of points just because there's so much stuff to do here. The actual probability distribution is just your x and your p of x. So my x's are 0 through 4. How do we get the probabilities for each? Okay. Look at my table. So my frequencies, if I add up all my frequencies, we get 100. So we just divide our frequency divided by 100. So 10 divided by 100, 50 divided by 100, 5 divided by 100. Oops. 25 over 100 and 10. Quick check, what should those add up to? 1. And we've got that right. And then I said you need to include the columns for x, p of x, and x squared p of x. So we're going to end up with 4 columns here. That's what makes this worth a lot of points. Not that the math is hard, but I'm asking you to add a lot of things to your table. So x p of x, 0 times 0.1, 1 times 0.5, 2 times 0.05, 3 times 0.25, and 4 times 0.1. Does everybody know how I get those numbers? X squared p of x, a couple ways of doing it. You could just take what we just got times our x, or you could go back and think 0 squared times 0.1. 1 squared times 0.5. 2 squared is 4 times 0.05. So does everyone know how to get those numbers? So then I asked you to graph it. I left it fairly open-ended. There are different ways you could draw this graph. I'm just going to keep it nice and simple. So my probabilities would go on my y-axis, and my x's are going to go down here. My highest probability is 0.25 or 0.5, so discount by a 10. And then I'm just going to put a dot at the probability and draw a line going to it. If you drew the curve over the top, because you're kind of trying to look at the shape, that's okay. If you drew them as boxes, that's okay as well. So then the mean, if you look on your formula sheet, under probability distribution, so that is under chapter 6, the first bullet, it tells you the mean is the sum of x times p of x. So I already had you make the x p of x column. All you have to do is add those up, and we get 1.75. Standard deviation from our formula sheet, it is the square root of the sum of the x squared p of x's minus the mean squared. So the sum of the x squared p of x's, so you add up this column, which gives me 4.55 minus the mean we just got, squared. Put that in our calculator, and we get 1.2196. I asked for the variance, which if you just look on the chapter 6, it doesn't mention variance, but we've seen it before. If you look on the front of your formula sheet, how do we find variance? Variance is just sigma squared And so we get 1.4875. Everybody okay with that? The next one, I'm asking you to use your table. So everybody get out the table and make sure you can follow along and find these. So I told you the N is 15, so that's the back page. X is 3, and the P of X is did I skip one?
8.
Oh, yeah, I did. Okay. All right, so let's look at just the binomial with doing it by hand. I just jumped straight to my table one, didn't I? Okay, so it tells us the N is 4, X is 1, and P is 0.3. So if I say to calculate it, that means I want you to do it by hand. You better show me work. So the formula, it's on our formula packet, it says N choose X. So 4 choose 1. P, so 0.3 to the X. 1 minus P, so 0.7 to the N minus X, so 4 minus 1 is 3. Does everybody remember how to put the choose in your calculator? So do parentheses 4, and then where do we go to? Math, over to probability, and the third one, NCR. So 4 choose 1, 0.3 to the first, and 0.7 to the third. I expect work. Make sure you're writing this line out. So B, I said we had N is 2, so 2 choose X is 0. P, so 1/4 to the X, to the 0. 1 minus P, so 1 minus 1/4 is 3/4, so we could do 0.75 squared. And if we put that in, and we should get 0.5625. Is that one okay? So then let's do number 9, where I have you looking on the table. So if it's on the table, there's not really a lot of work to show. So the N is 15, so we're on the back page. X is 3, P is 0.05. So you're in the second column. You go down to when X is 3. If you struggle with this, you might get some pieces of paper out, kind of cover up things and make sure you're looking at the right spot. So it should be 0.0307. Everybody get that one? Second one, my N was 8, so that's the back of the first page. Probability is 0.95, so that's the very last column, and we want X to be 7. And we get 0.2793. Then I did mean and standard deviation for a binomial, which are some of the easiest mean and standard deviation questions that we have. We know N was 11 and P is 0.05. Okay, so if you look on your formula packet, under binomial, so top of the second column in chapter 6, the mean is N times P. Standard deviation is the square root of N times P times 1 minus P. So my mean is just 11 times 0.05, which gives us 0.55. standard deviation is the square root of 11 times 0.05. 1 minus 0.05 is 0.95. And you get 0.7228. Is that okay? All right, then the next one, we talked about empirical versus classical probability. That's been a while. That was like the very first part of our probability piece. What's empirical? Expect.
Or
It's based off of true
Yeah, it's looking at what actually happened. What is classical? What we would expect to happen. So if I just flip a coin, I expect to flip a heads half the time. That is classical. But if I flip it 10 times, does that mean I will get 5 heads? No. So whatever I get is empirical. So this first scenario, die is rolled 5 times and number 1 is observed twice. So that's what I actually saw. So that is empirical. B, when I roll a dice, I would expect 1 to appear 16.67. That's 1/6 of the time. So that would be classical, what should happen. So empirical is what does happen. Classical is what I would expect to happen or what should happen. All right, number 12. So according to a survey, 20% of the victims say that it took 1 week to 1 minute to recover, or 1 week to 1 month to recover from identity theft. A group of 14 identity theft victims are randomly selected in your hometown. So we have 14 people. The probability that they recover is 0.2. Are those the only 2 options? They either recover or they don't? Yes, so we only have 2 outcomes, 2 possible outcomes. Hello.
Hello, Ms. Dreck. I'm sorry to interrupt.
No
But the
problem.
pop quiz mobile is here right now.
Oh.
And this is for our teacher.
Uh-oh.
Okay? She's used.
Okay, so we only have 2 outcomes. Either you recover or you don't. Fixed number of trials, only 14 trials. Everybody has the same probability of recovering. So what kind of experiment is this? Binomial. So we have, what's the probability that none of them were able to recover? So that's my x. It's saying none of them, so x is 0. So if I want to set this up, I'm only counting that 1, so we could do it as a binomial. You can do it by hand if you want. 14, choose 0. P, so 0.2 to the x. 1 minus p, so 0.8 to the n minus x. Could you do this one on your table as well? Yes. So either way, it's on the table. It can be done by hand. We know that sometimes that last digit is different, so just make sure I know how you're getting your answer, whichever way you might do it. And what do you get when you do it by hand? And I'll compare it to what we get on the table. Oh, we don't have a 14 on our table, do we? No, so you can't do the table on this one. I lied. No table. So we get 4398 or 0.044 if you round it up. B, what is the probability that between 2 and 4 we're able to recover? So that means x could be, when I say inclusive, that means including those, so it could be 2 or 3 or 4. So we have to do each one of them and add it up. Shortcut, guys, if you just put this in your calculator, we can, this should be 14, choose 2. So hit second enter and bring it back up and then just change. So we want 14 to choose 2, 0.2 squared, 0.8 to the 12. We want to do 14, choose 3, 0.2 cubed, 0.8 to the 11th. And 14, choose 4, 0.2 to the 4th, and 0.8 to the 10th. So easiest option, I think, is just to second enter and keep bringing these back up. So this is and so we get 0.6723. Possibly a slight difference due to rounding. Just make sure you're showing me where your numbers come from. All right. C. What is the probability that at least 5 we're able to recover? So that means it could be 5 or 6 or 7 all the way up to 14. So you could calculate all of those. The other option, we could think it's the complement of if x is 0, 1, 2, 3, or 4, right? We've already found 0, 2, 3, and 4. So if I could find 1, then I can subtract all those off. So if x is 1, that's 0.1539. So then I'm going to add my answers from part A, B, and that number together. And we get 0.1298. So different approaches. I just usually look for the shortest thing to calculate. Since I'd already found most of those, it was just one more calculation, subtracting them all off. All right, and D. The probability that no more than 4, so that means 0, 1, 2, 3, or 4. And yeah, that's the opposite of what we did on part C, or didn't we already find no more than 4 when we did part C? Yeah, it's that 0.8702. So basically it's the opposite of the answer we got in part C, 1 minus that. Okay, so you'll notice this packet was a lot shorter than the first one. So it was more targeted, so very similar to the types of things on your test. I told you there is one section of matching terms, and I gave you all 6 of the terms that will be there, so it's just matching. Are there any other questions for me? Yes, ma'am.
It's just like the life insurance one.
Uh-huh.
So you just do
The X